Good afternoon. My name is Chip Grote. I'm the interim dean of the Jackson School of Geosciences and director of the Center for International Energy and Environmental Policy. And I have the pleasure of moderating the second panel dealing with the renaissance in nuclear power, dangers and opportunities. And we'll discuss that, of course, in the context of the conference, which is Reducing Nuclear Threats, Nonproliferation Challenges for the next administration. I'm going to start by just saying a few words about the renaissance. The main topic of this panel is how the renaissance impacts proliferation. So I'll just lay the groundwork with just a few comments about the renaissance itself and then turn to the expert panel to pick up on their views and opinions on the relationship between the renaissance and non-proliferation. There are several conditions that have caused or emphasized the interest in nuclear power, resulting in the resurgence and causing what has been called by some a renaissance. Clearly, the growth in demand for electric power, both domestically and globally, is a significant factor in any plans to increase electric power generation. So nuclear power, in a sense, fits into a broader picture there. Also, concerns about traditional hydrocarbon fuel sources have caused a lot of interest in alternative sources of energy, including nuclear power. There have been some procedural things in the United States, at least, and I'm sure internationally, that have encouraged the nuclear industry away from the point where it was discouraged decades ago, and that relates to streamlining of license procedures in the U.S. and the potential for avoiding some of the lengthy and very costly delays that caused grave problems for the nuclear industry a couple of decades ago. There have been significant increases in the reliability and improvements in the technology of nuclear power generation that have taken place very quietly behind the scenes during this period when we haven't talked much about nuclear power. There's been a strong safety record, not to say there haven't been outages or issues, but no large-scale concerns of the kind that were expressed when nuclear power was on the downswing. And there's certainly been efforts from the Congress, financially and otherwise, to support the nuclear industry returning to being an increasingly significant player. But publicly, at least, and in the view of Congress, I would suspect there's nothing been more significant than the greenhouse gas friendly aspect of nuclear power. It is kind of at the heart of most discussions about increasing our use of nuclear power, going back to what was believed and has been a very stable and dependable baseload power generator, that the fact that nuclear power has negligible contributions of carbon dioxide and it only really occurs somewhere back in the life cycle has caused the great interest in nuclear power and the many stories about who now is for it that might have once been against it. And so we've seen a lot of interest publicly and more awareness publicly in nuclear power than we've had in a long time. However, there continue to be some of the concerns that were causes for the decline in interest, not to mention the capital costs, which continue to be an issue, while on the other hand, the availability of adequate fuel supplies is not as an issue as it has been with some of the hydrocarbons. The capital cost of the facility is still one of concern. We continue to have interest and concern about siting issues if we're going to build new power plants in sites away from existing ones. There are groups that are opposed to nuclear power on many bases, on many fronts, that continue to be opposed, and there's concern among the nuclear industry folks that these same groups will delay development of nuclear power by getting involved in the licensing process, the siting process, and leading us towards some of the same delays that we had in the past. And then there are the issues that we're really here to talk about today in this panel related to the renaissance in nuclear power, and those are the ones that relate to nuclear proliferation. Clearly, the access to fissionable material at either the front end or the back end of the fuel cycle is front page stories when it comes to what negative role nuclear power could play in the proliferation, and particularly in the United States, our seeming inability to handle the waste issue. The fact that the Yucca Mountain storage site, disposal site, is yet unresolved. The fact that we have nuclear materials stored at nuclear power plants around the country causes many people to be concerned about their availability and access by terrorist groups or people with not very good motives. The reprocessing issue in the fuel cycle is one that causes people concern, whether or not that increases the accessibility of terrorists to fissionable materials. And finally, the nuclear reactors themselves that are claimed to be used for peaceful purposes in Iran and in North Korea have been seen as many as one of the bad signs that intended uses or stated intended uses of nuclear power that seem to be friendly clearly are not that in many situations, and the proliferation of those kinds of entrees into nuclear power leads us to increasing concerns about proliferation. So this afternoon in this panel, we'll take the Renaissance as the background for the discussion today, where these folks, all experts in various aspects of proliferation, will talk about how the Renaissance itself relates to proliferation concerns, and they may very well offer some comments on the different elements of the Renaissance itself and how they feel that is germane. I'll just name the panelists in order and say that the format will be that each of them will give their views and their comments on these issues, 10, 12, 15 minutes. Then we'll give them a chance to ask each other questions, and then I may have a question or two, and then we'll, as the last panel did, open it to the floor and give you folks a chance to question them. So our first panelist speaking this afternoon will be Dr. Ray Uzaitis, who is chair of the Department of Nuclear Engineering at Texas A&M, and as you know, their bios are in the book, so all I'll say is that Ray has 3 decades of experience in the management and execution of national security R&D programs at DOE, so he's well-founded in this subject. Dr. Edwin Lyman, who's with the Union of Concerned Scientists in Washington, D.C. He's a senior staff scientist in the Global Security Program and a past president of the Nuclear Control Institute, an organization committed to nuclear nonproliferation. And finally, Dr. Steve Bogalski, who's an associate professor of mechanical engineering and director of the Nuclear Engineering Teaching Laboratory here at the University of Texas at Austin. And Steve has dealt with many aspects of our subject today, all the way from nuclear forensics and nonproliferation to reactor design. So with that, I'll turn the panel's discussions over to our first presenter, Ray Uzaitis.
Thank you, Jim. I'd like to thank the Robert Strauss Center for inviting me at this panel. They also invited me last year around the same time, and I feel less vulnerable that I used to be a nuclear weapon designer than I do because I am now an Aggie. And these meetings always seem to happen right before the game, you know. So as a token Aggie, I'll be careful with my remarks. As a nuclear engineer, and having worked in the national security programs at DOE, I've had the interesting experience of having experienced nuclear technology both on the weapons side as well as on the civilian nuclear power side. Trained as a nuclear engineer. Unfortunately, my PhD I was writing it right at the time of 3 Mile Island, and my hopes to design new reactors was not going to be realized. So I answered the call to national service in a sense because I did believe in the nation's nuclear policy of deterrence, and designing nuclear weapons for me was national service, and I had an issue with ethics and morality, and I dealt with it, and dealt with it for lots of years. But the world has changed now, and I have returned back to the nuclear power side. So this is very interesting. This confluence of, you know, nuclear technology is it a curse or is it a gift? You know, unfortunately, like many things in life, it's both. You know, there's nothing. You know, there's no more immorality of a nuclear weapon than there is of a nuclear reactor. It's what people do with them that really makes the issue something for consideration here. So let me say, first of all, the nuclear renaissance is definitely upon us, and I think the moderator did a very good job sort of overviewing, you know, some of the reasons for this. You know, the world faces huge needs for energy. That had nothing to do with nuclear power. That has everything to do with globalization and the need for the world and expectations in the world to develop their economies. And so developing your economy demands lots of energy. And so in the next 25, 30 years, you know, there are various projections, but it seems that the world is going to need 50% more power than it has now, which if you think about what it took to get to this point, and now 30 years, you want to take half of that and increase it, is quite a challenge. And the problem with that, of course, is global climate. It would be an easy solution if we could burn all that coal. But coal clearly, the influence of carbon dioxide, and I won't belabor it here, has created another constraint on mankind in trying to reach its energy goals. So when we look at baseload generation, where can you generate that kind of energy and manage an electricity grid in a reliable manner, besides coal generation, or maybe natural gas, which is expensive, nuclear is clearly there. And it has been supported both in the United States. We generate a huge amount of nuclear energy. Percentage-wise, at 20% electricity in the United States, nuclear isn't as large as it is in countries like France or Lithuania. Lithuania is something like 90% for a small country. It doesn't have a lot of needs, but the Russians left it 2 RBMK reactors, and it uses those to generate very important foreign exchange. So various countries have looked to nuclear, based on their own indigenous situations and relationships to fuel providers. France is a notable exception in the world. It made a command decision in the 1970s oil crisis. They didn't take a vote. The government decided that it was going to invest heavily in nuclear, and they did so in a very short order. And they had this huge growth campaign by the end of the 70s, early 80s. They are now 70% of their electricity, at least 70%, I think it's more actually, is generated by nuclear power. But now what we see is the growing countries, the growing need for power in countries like China and India. These countries have the greatest rate of growth right now, and they are grabbing energy. I guess we'll talk later about the Indians' need for energy and how they view nuclear power. But clearly, the Chinese are engaging in a large nuclear power development program. They're also engaging in a lot of coal development. I've heard anecdotally. I still need to see the academic literature. I guess I could, if I find it somewhere, have something to base it on. But I understand that 2,000 megawatt coal plants are being put online by the Chinese every week. This is a huge growth. So nuclear definitely provides a solution to mankind's energy problems. So what about this non-proliferation issue? Well, the fact of the matter is it's all about the nuclear materials. I think in the first panel they raised it early. Once nuclear materials in a reactor and producing energy, there's very little proliferation risk. Where the danger occurs is what you do to get the material, before you put it into a reactor, i.e. enrich it, and what you do after you're done irradiating it in a reactor. In some cases, recycle it. In other cases, store it. The United States, the fact that I guess reactors produce a significant quantity of plutonium is probably known to everybody. I assume everybody knows that. So, in the fuel that is taken out of a reactor, there's a significant quantity of plutonium. Is it the most ideal plutonium to use in a nuclear weapon? No, but it can be used. The worst part is it can be separated. So that leads us to our materials problem. Countries have addressed sustainability of nuclear power in several ways. The most obvious to an engineer is, once you take fuel out of a reactor, there still is a lot of uranium there that can be used. And if you could recycle the plutonium and burn that in a reactor, you could extend the life of the uranium cycle by significant numbers of years. So recycle, from a standpoint of engineering and sustainability, makes very, very good sense. Now, in the United States, in the 1970s, partly due to, and I think it got most headlines, non-proliferation issues, but also because of economics. The United States government decided not to pursue the recycle option. So all the nuclear power plants, they took the spent fuel out of the reactors, stored it on site, and are still storing it on site. In the meantime, the United States government passed a Waste Policy Act and said that it promises the utilities that they will build a repository, a federal repository, where that waste can be sent. That's been an on-again, off-again issue that's been broiling for 30 years. That facility is now in existence, is ready to be in existence at Yucca Mountain, but it has had lots of political opposition, mostly from the the good state of Nevada, and has basically bottled up our solution to the waste problem. Now, the French have gone a different route. They have recycled their fuel. The problem with the French approach is that it's based on a recycling technology that is optimized to separate pure plutonium. It was developed during the Second World War when the United States needed to get their hands on as much plutonium as quickly as possible, and they optimized the separation process called Purex, plutonium, separation, plutonium enrichment, I guess, extraction, plutonium extraction, Purex, process to do this. So, the countries in the world that are recycling, which include France, but also include the United Kingdom, Russia, and soon to be Japan in a big way, are recycling, and they are basing their recycle technology on this Purex process. This is the wrong process to have. So even though one says, hey, there's a lot to be said for recycling nuclear material in order to sustain the nuclear option better and to use the fuel better, this is not the way we should be doing it. The Bush administration actually had a visionary approach to dealing with this problem by introducing the notion of other recycling strategies that would never separate out pure plutonium. It was called GNEP, Global Nuclear Energy Project. Partnership, that's right. Unfortunately, in that, whether the vision was there, the execution of that initiative failed miserably in many different ways. Failed with Congress because it was done in secret and then hoisted on them. And then the Department of Energy took the money from the Environment Management Fund to fund this new project, which bothered a lot of constituencies. They did it in secret, as I said. The other thing is that they rushed to commercialization, and I think that's what eventually doomed it. The National Academy of Sciences was asked by the Congress to review the proposed program, and in a fairly scathing report, they slammed the GNEP initiative and basically said, hey, good idea on the recycle, bad idea on rushing to commercialization, because number one, the research and development that needs to be done has not been enough to justify it. They did not come up with an economic justification that made sense for that kind of a program. And unfortunately, and this is what bothers me as somebody who worked in the nuclear explosives business, they did not articulate the national security imperative to move the world away from Purex. Proliferation resistance was given lip service, but all the aspects of bringing that to the attention of those who could make things happen was simply not done. So GNEP is a failed initiative. However, it goes back to an R&D process right now, and so we wait. I think it awaits a new administration to see how to proceed on this. I think from my professional perspective, the United States lost the ability to lead the world technologically in this in the 1970s. As you could argue forever whether the Carter decision to stop recycle was the right one or the wrong one. It's no use crying over spilt milk in this case, but in some sense we abdicated our technological role to lead the world to a way of doing this that would not involve the separation of plutonium. I don't know how aware we were in the 70s of that happening. I don't think we were as much as we are now. After 9/11, the threat of a terrorist attack with material that has been accumulated, gotten, stolen, whichever way you want to say it, is clearly, I think, is dominating the nuclear security threat of our time right now. It's no longer the arsenal exchanges that we used to worry about in the Cold War. So I think there's a lot of discussion to be had, and I think Senator Nunn might even allude to it, how we put all of this, all these nuclear issues together. But to suffice it to say, the United States does not have the leadership role. The MOX process, the process of using Purex to produce mixed oxide fuel, which involves large quantities and growing every year of separated plutonium, is now in the world, and there are industrial and national forces and momentum that serves to keep it there. So when somebody says, well, you're going to, the United States is going to have this new process, how are we going to convince the world to turn away? It's not so simple, because we've also lost the leadership in nuclear power. Because since the United States has not ordered any power reactors in the last 30 years, if any of you have seen who our vendors are of nuclear power reactors these days, there's not one totally United States vendor. They have all been bought by foreign companies. Toshiba has bought Westinghouse, General Electric, Hitachi has bought General Electric, Areva has bought Babcock and Wilcox, and the story goes on. So American industry is not in much of a position to lead the world that way. And the United States government, despite the GNEP program that was initiated, also was not in a position to lead the world, in a way that pointed to proliferation resistance. So, bottom line, I'll conclude my remarks, is that the nuclear power renaissance is on a threshold. Key issues for sustainability, as our moderator said, are there are 4 issues. One is nuclear safety record. If we make a mistake on a safety issue in nuclear power, the renaissance, you can kiss that goodbye. Financing and future of loan guarantees. There has not been one spade of dirt yet turned for a nuclear power plant. And yet, as a department head at A&M, I know that every one of those students is getting fantastic job offers. There are companies gobbling them up, and the Nuclear Regulatory Commission is gobbling them up because everybody foresees a big future. But without those loan guarantees, the capital needs are not going to be met by these companies. Each of these units is about $5 or $6 billion. They usually build them in packs of 2, so you're talking $10 billion. The capitalization of some of these utility companies is like $15 billion. So you're really asking a company to bet the store on investing in new nuclear power. So everybody is waiting to see how these loan guarantees that were originally identified in the Energy Policy Act of 2005 will proceed as the government transitions to the Obama administration. And oh, by the way, financing has gotten difficult in all areas, and so this is not the best time to be looking for money to borrow. So that's a cautionary note. A comprehensive solution to the waste management problem awaits to be seen, how we will deal with that. The Obama administration, what we hear is that they really do not like the idea of Yucca Mountain, and it's not yet clear how they will move in that area. And then finally, the issue of nuclear material security and proliferation risk. The danger that is there in terms of accumulating lots of material and lots of plutonium is something that needs to be attended to, and I think that's an engaging imperative that calls the industry to.
Thank you, Ray.
Yeah.
Ed?
Hi, again, I'd like to extend my, can you hear? Yeah. Extend my thanks to the Strauss Center for the opportunity to participate in this very interesting forum, and I'd like to thank Ray for setting things up, because I have to say I have a different view about some of the things he's raised, especially the merits of the vision of the Global Nuclear Energy Partnership Program. I come from the Union of Concerned Scientists. I'm based in Washington, and we aren't one of the groups that Dr. Grote referred to as being anti-nuclear. We are agnostics, but that isn't to say that we're not concerned about it, and we will speak up, and we will be aggressive when we think that things are going in the wrong direction. And we think there has to be a very high standard for the safety and security of nuclear power plants before we could envision the type of renaissance that for which there's such a heady optimism in some quarters today. I'd just like to say on the question of the renaissance and whether it's real or not, that Areva, the U.S. subsidiary of the French company that Ray just referred to, recently, or just yesterday, announced that it couldn't get the financing to build a new office building in Lynchburg, Virginia, to house staff, so it was going to rent for the time being. So I'm not sure what that says, but it's I think it's a signal. Can we really envision a nuclear renaissance that on the scale that people are talking about, of potentially 1,000 new nuclear plants around the world by the 2030s or 2040s, and not create an unmanageable situation with regard to the threat of nuclear proliferation and threat of nuclear terrorism. If you look at the state of the nonproliferation regime today, you can say that it's already in a struggle. Some may say it's in a crisis. And it's not just the ongoing situation in North Korea or Iran, but there are a whole host of other issues that have arisen in the last few years that raise some unique issues of their own. The situation in South Korea, in Egypt, Brazil and Japan also pose issues of their own, which I can go into in more detail. The safeguarding of uranium enrichment plants in nuclear weapon states as well as non-nuclear weapon states poses another challenge to the regime. These are all serious issues dealing with the scale of facilities we have today. And so to envision the impact on the nonproliferation regime of an uncontrolled expansion on a large scale, in my view, you need to look at the current state and be able to extrapolate it. I mean, if there's no good evidence today that the situation is in hand with regard to controlling the proliferation, terrorism risks of nuclear power, I don't see how you can go forward with a large-scale expansion with a straight face. So I have my own set of criteria that I think are essential if there is going to be a nuclear renaissance, how that can occur without an unacceptable increase in the risk of proliferation terrorism. The first is obviously that the spread of uranium enrichment technology has to be stringently controlled and on a verifiable and a firm and a non-reversible basis. Unfortunately, while those goals were originally elucidated by the U.S., the IAEA, and other parties over the last few years, we've already drifted away from firm standards in that regard. Second issue is that there have to be adequate resources for developing effective international safeguards on nuclear facilities and for implementing those. Now, it's well known that the IAEA Safeguards Department has been under serious financial constraints for a long time. Only in the last couple of years were they allowed to raise their budget beyond what was called no real growth. But even so, the level of it's still in the, I think, around $120, $130 million a year range, which is really peanuts compared to the importance of the mission of the IAEA. So obviously there's already an imbalance with regard to the resources available to safeguards and its importance, and that's only going to increase if there's no new mechanism for financing safeguards. The next criterion is that I believe there has to be a worldwide ban on the commercial reprocessing of spent fuel, whether it's using the Purex process that we just heard about or the modifications that the Department of Energy has been advocating, which I've analyzed in detail, and find that there's a lot less than meets the eye with regard to the technical merit of those proposals. And tied to that, there has to be a credible mechanism for developing repositories for spent fuel. It has to be credible both technically and politically, because it's not enough. You often hear the statement that spent fuel repository is a political problem, but it's not a technical problem. But those political problems are formidable. So even if that were the case, that's not an answer. And there are also technical issues as well, which I can talk about. Now, the solution that the Bush administration proposed for dealing with the proliferation risks of its very aggressive drive to increase nuclear power around the world was this Global Nuclear Energy Partnership Program. I'm not convinced it's completely dead, but certainly it's in trouble and it'll be reevaluated by the Obama administration. And I don't agree that the fundamental vision of GNEP makes sense. So I'm actually not that happy that its execution was so badly bungled by the Department of Energy. So I'd just like to explain why. GNEP had two components. One was really related to a variety of different international proposals that somehow the fuel cycle worldwide should be internationalized, that somehow if we could come up with a system where the fuel cycle facilities like enrichment plants or reprocessing plants were restricted to a very few number of safe quote-unquote countries, and convinced others who want access to nuclear power that they should forego their own domestic enrichment and reprocessing plants. If there were a system in place like that, that we would be able to effectively curtail the spread of sensitive facilities that could be misused for nuclear weapons purposes. Now, the problem with here's an example, and this is not a new idea. Most people who've been around a long time will say that the Atchison and Lilienthal plan was the first manifestation of that, and it hasn't really had much success since then. But the idea keeps coming up, and a number of analysts use that as a panacea when they're confronted with how do you justify a large-scale expansion of nuclear power without causing a proliferation crisis. They cite efforts to internationalize the nuclear fuel cycle. Well, fine. If it could happen, it would be great. But the fundamental premise is flawed, and the major flaw of the primary flaw is that those countries that we would be most interested in having participate in this system, in other words, renounce their own national fuel cycle facilities and have access to some international assurance, those are exactly the countries that would be least interested in, or least trusting of that kind of a system, like Iran. You can't, there's no fuel cycle assurance mechanism you could come up with that would satisfy a country that's not on good terms in the international community and is mistrustful of the international community. So, and that's manifested itself that there's been a standing offer for several years for Iran to obtain rich uranium from Russia and exchange, and they still have not accepted that offer or made any effort to forego their own domestic enrichment. And just from a nationalistic perspective, it's hard to imagine any leader preaching energy independence and signing on to essentially permanent dependence on this international system. Of course, the United States and the catechism we hear now, of energy independence doesn't help. So that fundamental premise, the countries that we can get on board are the ones that we're probably least worried about. Now, there is one recent exception, that's the United Arab Emirates, which has stated that it wants to pursue a nuclear power program but doesn't require its own domestic enrichment. However, they don't know what to do with the spent fuel their nuclear power plants would generate, and they're actively seeking international options for that. So I can get into that later. The National Academy of Sciences summed this up in a recent report where one of their conclusions was few countries have declared a willingness to forego a right to develop enrichment or reprocessing, and some countries have expressed adamant opposition. So that really is the current situation. Now, they also found that just providing uranium is not a big enough incentive to get countries to buy into the system. A much more potent incentive would be to provide a mechanism for taking spent fuel out of the country. And, in fact, GNEP and other proposals have given lip service to the idea that there would be some country, one of the fuel cycle states, would take spent fuel out of away from the countries that renounced their own enrichment and reprocessing plants. Unfortunately, there is no viable candidate for a country that would be willing to do this. So until actually a country steps up to the plate and says that we're opening our doors, we will be the recipient of foreign spent fuel for final disposal, that option is not credible. Now, I heard Jane Harman in Washington only a few weeks ago, a congresswoman on the Intelligence Committee in the House, who is opposed to Yucca Mountain, but said that she would be willing to contemplate changing or actually weakening the law to facilitate foreign spent fuel coming into the United States for disposal. But of course, if we can't even honor the promise that the Department of Energy made to the utilities to take spent fuel by 1998 from one state to another, to a repository, I don't know how anyone would believe that the United States would honor a promise to take spent fuel from other countries. It's just not credible. So unless there is some credible mechanism for that kind of enterprise, it's just hard to believe that it's going to happen. Now, getting to the second part of GNO, which was the development of so-called proliferation-resistant reprocessing, this actually leads to a fundamental contradiction in the whole concept, because if reprocessing is only a proliferation threat in certain places, why do we need to develop proliferation-resistant methods if we're only going to restrict fuel cycle states to the so-called safe countries? On the flip side, if we develop processes that we say are proliferation-resistant, how can we deny that technology to other countries? And there's a practical example of that with regard to South Korea, which is very interested in obtaining U.S. consent to start operating a facility in its country which would engage in a type of reprocessing which the United States has been developing for years in Idaho, which it claims is proliferation resistant. The U.S. so far has not provided consent, causing South Korea extreme frustration, and their response is, well, what is the issue if you say that this technology is proliferation resistant? So the U.S. So the fundamental concept is flawed. Now, actually, in practice, none of the options that are being studied actually do the trick of removing the threat associated with reprocessing. Because the problem with reprocessing is that a spent fuel assembly from a nuclear power plant, which is not something that can be readily stolen and processed by a terrorist, because it's generally weighs about half a ton, it's 12, 15 feet long, and it's so highly radioactive that you can't physically handle it. It has to be carried within heavy concrete shielding and processed behind shielding. So it's not practical for a terrorist to steal a spent fuel assembly. However, that spent fuel assembly, after reprocessing, you'll have about 4 to 5 kilograms of plutonium from each pressurized water reactor spent fuel assembly you reprocess. And that 4 to 5 kilograms is sufficient to make a nuclear weapon, and it can also be carried on someone's person without causing serious physical injury, because the radiation from purified separated plutonium is not as potent as that in the spent fuel assembly. So reprocessing actually does the terrorist job for them by committing this enormous industrial enterprise and all the expense and difficulty of reprocessing to turn spent fuel into a material that can be stolen. Now, proliferation-resistant reprocessing would be, can you somehow restore some of the proliferation resistance of spent fuel so that it would be harder to steal plutonium? But none of the options that the Department of Energy is reviewing actually accomplishes that. I can go into that detail later. Even worse, these reprocessing technologies, by making the material you're working on more complicated, you're also increasing the difficulty of measuring and accurately accounting for the special nuclear material that you're processing, and that increase actually decreases the effectiveness of safeguards. International safeguards means you have to verify that a country is not diverting nuclear material from a process like a reprocessing plant or a fuel fabrication plant. That depends on having accurate accounting of nuclear material, and when you're talking about a plant that processes 8 tons of plutonium a year, when 1,000th of that is enough to make a nuclear weapon, you realize you cannot, you have to be able to account down to the kilogram quantity. It's already very hard or impossible to do at large-scale industrial Purex facilities like we heard about before. It would be even harder with a facility that has one of these more complicated reprocessing technologies. So you're actually reducing the effectiveness of safeguards. And I guess I have a lot more to say, but I think I'll stop there since I'm probably over time.
We'll have a chance during discussion. Thanks, Steve.
Okay.
Wrap it up.
Wrap it up. All right. So, Dr. Key.
Which side are you on?
All right. So again, I'd like to reiterate my appreciation to the Strauss Center for hosting this today and inviting me to be a member of this panel discussion. And I think we have a very interesting topic here, and the reason is that we have really a conflict within policies here. We have something that's basically our energy policy. And when you look at just things from an energy policy perspective, we look at it and we say, hey, we're growing in energy, and the United States is growing in its energy demand, but our demand that we have here in the United States is minuscule in comparison to demand in areas of the world, especially like Pacific and East Asia. So we have a real growth in energy needs around the world. And we look at an energy policy point of view and we say, how do we get that energy? We can look at things and people can be all glorified and say solar and wind are our solution. But we know that those aren't really the sole solutions that can happen. Solar has its problems, and we can talk about the limitations of that today. But even wind, which looks more promising, we can't necessarily utilize to supply all of our power. There are limitations at which wind can actually provide our power. And we've even seen those limitations within Texas. Just this last February, West Texas, they have a large portion of their power coming from wind power. There was a day when the wind didn't blow. They had to actually shut down parts of the Texas grid in order to prevent a statewide blackout. And that's only at a 3% contribution of wind power to the total state electricity budget. So what we're really looking at is where do we get our power supply from? So then we come down to coal and nuclear, right? Both are very viable options. And we go and we weigh in greenhouse gas emissions. And really what comes out when you look at cost, reliability, ability to produce power, nuclear really comes out on top, all right? And so we see how when you go through that type of analysis from an energy perspective, how nuclear really can come to be a very prominent player within energy policy. Now we do recognize, and that's why we're having this discussion today, that those policies are in conflict with what we'll say nonproliferation policy. We can go back to guys like von Hippel, who visited us last year, and he has a particular point that says plutonium is bad, nuclear reactors produce plutonium, therefore no nuclear reactors, right? I can say, all right, I see your argument, and that's a very, very simple argument for him to have, but the problem is that our world is not that simple. It would be nice to say, hey, let's have everybody be peaceful. No one will ever go to war. No one will ever do bad things, and we're all going to live together in harmony. And by the way, anything bad will never, ever, ever, ever happen. The problem is that we do need this energy, and we do need it from nuclear power. And we have to figure out mechanisms in order to, meet our energy demands without causing undue proliferation in the world, right? So again, I can make that statement. It's pretty easy to make. But in order to look at that statement, we actually have to look at a divergence of policies as well. Number one, we're not only looking at policy within the United States, because I can actually say United States policy, just concerning ourselves with what happens within our own borders is relatively easy, right? We have a large degree of control over our nuclear power plants, lots of exercises with the Nuclear Regulatory Commission, looking at design basis threat scenarios to try to prevent do the best to prevent force-on-force problems. We have a large degree of control. We're not necessarily worried about the United States developing nuclear weapons because we already have them. So the United States is a very, we'll say, a relatively easy problem that is within our control. The thing that is, of course, the problem is what's not in control. And, of course, that's always what we're going to worry about. And the big problem is, and I guess we can say this, is that as a country goes and wants to develop a nuclear reactor technology, we're not talking about something that is not 50-year-old technology, right? If a country really decided to take upon their efforts to develop a nuclear reactor program, that the technology is there and they could do it with or without international assistance, depending on how desired they are, how much desire they have to pursue that path. So one of the things we really have to look at is assuming, and I guess I will assume, that other countries, whether or not we want them or not, will pursue nuclear technology for energy needs. The big point is to how do we take it and be able to prevent those reactors from producing plutonium. And I do find this to be a little bit of an interesting problem, and I guess I'll state it here, is that any nuclear reactor can produce plutonium. And not only can any reactor produce plutonium, if operated intelligently, any reactor can actually produce weapons-grade plutonium, right? So with that said, that any particular reactor operated in a manner that may not be commensurate with how we want to operate commercial reactors are potential sources of weapons-grade plutonium. And to me, this really comes down to one main solution. And I think that what we really have to push for from an international basis is really a complete control of the nuclear fuel cycle. I'm not, and I understand that countries like Iran want to sit there and say, I don't want you to have control of my nuclear reactor fuel cycle. And I can understand why they might want to say it, but the reason why I interpret that is because they want to use it to build weapons. It's just my own opinion. But the other point is that there is really no reason that they have not to allow, I guess, international control of nuclear fuel cycles, other than the sense that they just don't believe that the international community will live up to their word and provide the fuel and the waste. Now, how do we actually make that happen? And what I'll really say that the crux of this problem, and I really will say that the crux of it, whether or not we put in reprocessing, no reprocessing, once through fuel cycles, etc., that really the crux is final burial, right? Because no matter what we do, we can reprocess, we can come up with all these numbers, there's still going to be some degree of waste, right? And until some country, and I'll actually point to the United States, because I firmly believe that the United States should take a very large leadership role regarding nuclear waste from a global perspective, that the United States really needs to take the bull by the horns and take the waste repository issue and really make it a reality. And again, we can get into debates of whether or not we are there right now. But I will say with regard to Yucca Mountain, something of recent good news that hasn't been mentioned today is that finally the Department of Energy within recent months, I think it's only a month ago, actually finally submitted the application of licensure for Yucca Mountain to the Nuclear Regulatory Commission. We also know that the Obama administration has actually spoken against Yucca Mountain, and that is of concern. But the real point is both from a commercial reactor power production energy point of view and from a non-proliferation point of view, I think that the final crux focus point to make things happen really is on the final repository of the waste, and to be able to not necessarily say with foreign countries that that waste has to go somewhere, we have to control it, and having the final repository is the real way to make that happen. Again, you can put in reprocessing if you want, but again, with my main solution there is that I have to say that we do need to be, that the United States does need to take a leadership role within this, and that one of the main focal points I'd really like to see, again, both from the commercial nuclear power perspective as well as the non-proliferation perspective, is to push real hard to make final repository of high-level nuclear waste a reality and not just something that is being talked about. Hopefully I even cut that a little bit short. Thanks.
Amazing. Very good. Thank you. Let me provide the opportunity for panelists to ask each other questions or reflect on what each of you said. Ray, go ahead.
Yeah, I find it difficult because there are some things I agree with my colleague here, Ed Lyman, and then some things I don't. And a lot of it maybe has to do with ultimate faith that we have in the ability of technology to come up with the solutions that our diplomats and our policymakers are struggling with. I saw that firsthand, when we were dealing with nuclear testing. The arguments that we could not sustain our stockpile without testing were clearly articulated for many years until the technical community took with leadership from Washington. And that's what's very important, is to have the leadership from Washington and the budget authority to redirect programs. The technical community was forced to think about what it would take to certify nuclear weapons without nuclear testing. And the result of that was the greatest influx of scientific understanding about things nuclear and nuclear weapons since the Manhattan Project. And that was a science-based stewardship program. And that allowed the United States, to be in a position to ratify the CTBT treaty. Why the administration didn't, once we have lived with it, why we don't take the final credit for it and just ratify the thing to give the United States credit in the world community is beyond me. Because we as technologists did our part of it. We told the United States we could figure out a way to do this. It's the same way that I view nuclear, the issues of recycle. Now, clearly, you don't have to recycle. The question is, does that make nuclear power less or more sustainable as an energy source? You would say less sustainable, because recycling, forget about plutonium for a second, reduces the volume of waste by a factor of 20, reduces the radiotoxicity of the fuel, which means how long is it going to be radioactive, from hundreds of thousands of years to hundreds of years, which makes it a much more tractable problem for ultimate waste disposal. And it reduces the heat load, on an ultimate repository in a dramatic way. So it would make Yucca Mountain solution much more amenable to accommodate, the fuel of the used fuel of other countries, if you could recycle it and do it in a proliferation-resistant manner. Some questions about proliferation resistance. I'll also say it's not any one waste. Proliferation resistance is like safety. It's a characteristic of an entire system, from the time you mine the material to the time you dispose of it. It's not just a reactor that's proliferation resistant or a recycling technology. It's how you watch all of the material streams and make sure that at every point you can, that it is not attractive material for a terrorist. And so, to me, that is an engineering challenge that, unfortunately, U.S. and world industry has not addressed. And that's my big pain with my own industry, is that the issues of the non-believers in sustainable nuclear are able to point at us because we don't take the bull by the horns and do a technical job to do it, and it can be done. So bottom line for that is the United States government has to take a leadership role in here, and that's where I think the failure is.
Good. You want to reflect on that?
Sure. Well, first of all, on the other merits of reprocessing, which I didn't go into in any detail, but we have many people have examined the claims associated with waste volume reduction, heat load reduction, radiotoxicity reduction, and actually all of them fall far short of what are promised, and I don't want to go into the details. But first of all, with regard to waste reduction, if you only look at the high-level waste stream associated with reprocessing, what you're doing in reprocessing is 95% of what's in the spent fuel is uranium. That's actually uranium of a different isotopic composition than what you put in. In particular, it has higher accumulations of certain uranium isotopes, which actually make it a pain in the neck to actually use a nuclear reactor. First of all, you probably have to re-enrich it, and at the same time, you then increase the concentration of these undesirable isotopes. So as a result, the countries that have been cited here as actually recycling don't recycle that 95% of the uranium. In France, for example, it's piled up in storage, where only about 1% of it is actually recycled on the pilot basis, but the market price of uranium is nowhere near high enough to justify actually re-enriching that material compared to virgin uranium. So it's a misnomer to say that it's being recycled. As far as the toxicity reduction, you're extracting plutonium and possibly other long-lived actinides from spent fuel. But unless you actually can effectively reduce the material that you're extracting from spent fuel in a reasonable period of time, it's a shell game. That material is not actually being disposed of. You're just moving it to a different place. And the National Academy of Sciences in 1996 did a very exhaustive study where they looked from very basic principles at what it would take to actually take that cohort of actinides that you've extracted from spent fuel and process it through a system to reduce it to the point of view that if the system crashed at one point, you wouldn't be stuck with a cleanup mess 50 or 100 years from now and end up having to find a hole in the ground to dump it all anyway. And it turns out, because of the sluggishness in that system, it would take hundreds of years of continuous reprocessing and recycling to reduce that amount of material to the point where you would be left with only a small residue. And that, to me, does not satisfy one of the basic criteria of sustainable or responsible nuclear power, is that our generation does not leave a legacy for children and grandchildren to deal with. But in the kind of system that we're hearing about, not only our children and grandchildren would have to rebuild this whole population of plants over and over again and operate them for hundreds of years to achieve the endpoint that we're hearing about. So you're not, if you do an apples-to-apples comparison, you're not, it's misleading. I guess I'll stop there.
All right, hopefully I won't take too long, but I think what we're really looking at, and I don't even want to, I guess since we're on reprocessing, I'll make my own comments there, and that is, first, I will agree that as of today, we're probably not there where we need to be for reprocessing. Fine, not going to even argue that. The point is that what we have to do is we want to be optimists or pessimists, and I'll tell a little bit of a story where this whole thing began. Back in the 1930s, the Germans wanted to evaluate the prospect of a nuclear weapon. Heisenberg went and made some rough calculations and sort of said, you know, this whole thing of a nuclear weapon looks pretty difficult. The sizes may not work out, and we're going to make a decision here in Germany not necessarily to heavily pursue a nuclear weapon technology because we think that this is sort of hard and it may not pan out. Right? The United States, on the other hand, I guess probably Fermi may have been one of our leaders, sort of looked at it and said, yeah, it's difficult, but we think we can make it happen. Right? And as a result, that difference of opinion has changed the world as it is today, right? So when you look at things, you got to really understand, and I think that's where we got to go with this, is we got to say, okay, this is a hard problem, right? But we got to make the dedication to tackle it and make it happen. If we just sit back and say it's a difficult problem, it's never going to happen, it won't. And as a result, there are serious political consequences and worldwide history consequences as a result of whether or not we want to be leaders in this and make this happen, or we want to sit back and say that it's not going to happen.
Well, both you and Ray have made the point that the technology capability is there but hasn't been applied, that it hasn't stepped up. Mm-hmm. What would it take to make the technology more vigorously pursued? Is it a private sector issue? Is it a DOE lack of investment issue? And do you have any hope that in the near term that kind of investment will come from the federal government?
So I don't think it's a private industry. First of all, the United States right now, the interest that U.S. reactor vendors have in recycling is not that great. The power plants that we're going to build, in this next phase if the first phase, are going to be very similar to the ones we've built before. The whole point is that it's the Generation 4 reactors that should be the ones that are designed for the future, and that'll take some time, to evolve. So we do have time, to do this, but it's not going to. Industry does not have the incentives yet. And I think the National Academy said that right. The economic justification isn't there to justify that much federal investment. But what the federal investment can be done is in a much more vigorous R&D program. If we put as much money, into the R&D on these issues as we do in some other areas, that are nuclear related, and we also put in the R&D into advanced safeguards. So Ed and I agree completely about the need for a transformational advanced safeguards program that can stand to use the benefit of advanced technology in measurement technologies, in information technologies, basically to create this real-time situational awareness of materials. And that can be, so all of these problems just need to be invested. But I don't think industry right now is incentivized. But, that's, it's like the auto manufacturers. I mean, in the mid-'70s, they knew there was going to be this crisis in fuel, mileage and oil's going to run out, but they still made cars going, and then they come back and without saying one way or the other whether I agree with whether they should need a bailout, it's the same with the nuclear industry. I mean, they're going to make reactors that they are incentivized to make right now, and proliferation resistance to them isn't something they can sell. It's like seatbelts in cars. Why do I need to add this extra cost to my machine? So the government has to incentivize, the industry to take a leadership role in those areas. So it's a combination, but I don't think you'll see the lead from industry right now, and it shouldn't be there.
Can I comment? Or do you?
Ed, you can make a comment, and then we'll open it up to the folks.
Getting the point of whether this is a technical problem or not, I think there's pretty broad general agreement that the proliferation or solving the proliferation problem is there is no technical solution, that it's embedded in a larger political system, and there's there's no technical fix or silver bullet that is going to come up with a proliferation-resistant technology that will be effective enough, regardless of the political context, to work, a walk-away safe, proliferation-resistant system. And that point has been reiterated since this was looked at in the 1970s. There was the International Nuclear Fuel Cycle evaluation conducted by President Carter, where incidentally they studied all the ideas that are now still being talked about as proliferation-resistant. They were evaluated in the 1970s, and they came to the conclusion that none of them had enough technical merit to justify further development. So we're relearning history here, but even the current Department of Energy and Dennis Spurgeon, who's the Assistant Secretary for Nuclear Energy, in the GNEP strategic plan made the same point, that there is no technical solution. So it's not a matter of just throwing R&D money at this, it's whether or not the basic premise has merit. And as I said before, if you don't have a reprocessing system that provides enough intrinsic self-protection as the spent fuel that comes out of nuclear reactors, you are increasing the vulnerability of that system, and that has to be compensated for with enhanced security. And we haven't even discussed the issue of physical protection, which is a whole other can of worms, but there is not adequate funding for the level of physical protection for our current nuclear power plants that's needed. And as a result, if you were to start providing commercial nuclear power plants with materials that are weapons usable, they would need to enhance their physical protection beyond what they already provide, to the extent that the financial impact and the operational impact in these facilities would be very formidable. So it's something that technology is not likely to have the final solution for.
Ray, quick response.
I'd like to answer that issue. That is absolutely the right approach that needs to be used to incentivize the whole issue of proliferation resistance, because it's a trade-off. The more you can design the proliferation resistance into the system, the less physical protection you need. And it's going to be a trade-off between guards, guns, and gates, and technical features. Technical features won't do it by themselves, but they can reduce the risk to the point where you can make decisions and go forward. So it's, for me, it's all a matter. I mean, we did the same thing with safety. For a long time, everybody said, nuclear reactor safety. Then they said, well, let's quantify it. Let's start, doing probabilistic risk analyses, and let's see what the costs are, and it's the same thing with resistance. I mean, so there's an engineering approach to the problem that, there is no silver bullet to this, but unfortunately there's no silver bullet to accidents in cars, and yet we all decide that we're gonna buy cars because we want to get to someplace. So society is always in a position to be managing risks, reducing them where they can and accepting them where they can, and where society draws the line on those risks determines where civilization goes in a particular area.